We are now focusing on the sum formulas for both arithmetic, sequence, and geometric. So we'll just have to write down the formulas. The sum formula for arithmetic, it's Sn is equals to n over 2a plus n minus 1 d. So this is some formula for an arithmetic. Another formula that you can use, but this one is conditional, we'll use it when you are given the last term, where it's Sn is n over 2 a plus l. This is another formula we can use, but it's conditional because you'll only use it if you are given the last term. Now we'll be focusing on the sum formulas for the geometric sequence. Then we go for the first one, which is Sn. It's a Rn minus 1 all over R minus 1, of which it has a condition, which is R must be greater than 1 in order for you to be writing this formula in this form. Then you have this one, which is Sn is equals to a 1 minus r to the n 1 minus r. Then the condition for this one is that r must be less than 1. Then we also have, for the geometric sequence, we also have a sum to infinity, which is the sum to infinity is equals to an a 1 minus r, of which the condition for this one is that r must be between minus 1 and 1. And the sum to infinity, we must note that it only exists for a geometric series. We don't find it this side on our arithmetic. So these are the formulas we will be using whenever, because now we are about to do this the sums that require us to use the sum formulas. So next up we'll be doing the sum, the example 1. Example 1, where we'll have a 1, 3, 5, 7. So we are given this sequence 1, 3, 5, 7, and it falls under AR. It's an arithmetic sequence. So to have a question that will say determine the sum, let's just go for our A. Determine the sum. Determine the sum of the first three terms. The first three terms. Let's go for from the above. From the above sequence. So we are given 1357 as our arithmetic sequence, and the question is determine the sum of the first 3 terms from the above sequence. So now it's given that is an arithmetic. So since I'm looking for the sum, the key words is sum of the first 3 terms. So then, since it's an arithmetic, we'll go for an arithmetic sum formula, which is Sn is n over 2, 2a plus n minus 1 d, where if I was to explain this formula, we'll go for Sn, it's n over 2, 2a plus n minus 1 d, where n is a number of terms, and a is still our first term. Still our first term of the sequence. N is still a number of terms. Then D, it hasn't changed, it's still our common difference. So we are going back to our sum. Determine the sum of the first 3 terms from the above sequence. And the formula is Sn is equals to n over 2, 2a plus n minus 1 d, close brackets. Then from here, since they said it's the sum of the first 3 terms, so they gave you the number of terms. We take 3 as our n. So our n is 3. So this is a sum of first 3 terms. Where there is n, I put a 3 all over 2, and 2, a is our first term. First term for this sequence is 1 plus n is a 3 minus 1. Then our common difference, we'll have to look into our sequence. On our sequence, we are given a 1, 3, 5, 7. So using the formula, or just doing it manually, you can subtract, say, a 3 minus 1, you get a 2, a 5 minus 3, you get a 2, a 7 minus 5, you get a 2. Therefore, we conclude our D is a 2. Then we go back to our sum. Our D is a 2. Then sum of 3 terms will have a 3 over 2. Then here inside, since we are having a Bodmer's rule, we have a 2 times 1, which is a 2, plus a 3 minus 1, we get a 2, times a 2. Close the brackets. Then from here, we get that this is a 3 over 2, and this is a 2 plus a 4, which is the sum of 3 terms. It will give us a 6. 6 times a 3 is 6, 12, 18. You'll get an 18 over 2. Half of 18 sum of 3 terms, it's a 9. So you don't have to do it manual. From here, you can just punch into your calculator, then you'll get an answer as 9. Example 2, we will go for find the sum, or let's start with the question. Given an arithmetic sequence, 2, 4, 6, 8, 10. Let's take it to 12. Then the question is, find the sum of the first 5 terms. So, given an arithmetic sequence 2, 4, 6, 8, 10, 12, A is our question. Find the sum of the first 5 terms. So, because of our sequence is under arithmetic sequence, we now go on to use the formula. Roman figure 1, we use this formula to find our D, which we go for the T2 minus T1 is equals to T3 minus T2. Our T2 is a 4, our T1 is a 2, equals to our T3, it's a 6, minus our T2, which is a 4. Then 4 minus 2, we get a 2. 6 minus 4, we get a 2. Therefore, D is equal to a 2. Then, the question is, find the sum of the first 5 terms. So, on our sum formula for Roman figure 2, our sum formula, which is Sn, it's n over 2 2a plus n minus 1 d. So on our sum formula, for n, we need to know we are finding the sum of how many terms? Find the sum of the first 5 terms. So meaning that we are finding the sum of first 5 terms. Where there is n, I place the 5, therefore same goes for our formula. This is our 5 over 2. Then this is our 2, our a being our first term, we get 2 plus our n is 5 minus 1. Then our d, we did calculate our d, we got a 2, then close the bracket. Then the sum of 5 terms, you will then punch this as it is on your calculator, and you'll get your sum to be 30. So the sum of the first 5 terms, looking into this sequence 2, 4, 6, 8, 10, 12, the sum of the first 5 terms is 30. Under arithmetic, so for example 3, we'll go for this sum given an arithmetic sequence. Given an arithmetic sequence, let's go for a 5, 10, x, 20, 25. For the first question, we can go on to say, find the value of x. For the second question, our B, we find the sum of the first let's go for the sum of the first 4 terms of the first 4 terms. So for our solutions, answering A, we are given an arithmetic sequence 5, 10, x, 20, 25. First question, find the value of x or determine the value of x. So for this one, we must remember that for us to find D, we forever use this formula, T2 minus T1 equals to T3 minus T2. So now, this is the same formula we'll use to find the value of x. Then now, if we go on to write T2 minus T1, T3 minus T2, we will then take our T2 as 10 minus T1, which is 5. Then our T3, take note it's x, T3 is x, our T2 is 10. So now we have this unknown x, then we solve. We will then have a 10 minus 5, we get a 5. Then we have x minus a 10. Then we take our 10 to the other side. The sign will have to change. We get a plus 10 being equals to x. Then this is our x being equals to a 15. Then we just have to place it. Therefore, our x is actually a 15. So we've answered A, which required us to find the value of x. So our x is 15. So now we have a sequence 5, 10. We now have our value of x, which is 15, 20. We'll then use this sequence to answer the next question, which is our B, which is our B. The question was, find the sum of the first 4 terms. Now, We remember that we are still under arithmetic sequence, so we'll go on to find the sum. So we write down the sum formula for an arithmetic sequence. Then it's 2a plus an n minus 1 d. Then now go back to the question. Find the sum of the first 4 terms. We take our n to be 4 because it's sum, so it's sum of 4 terms. Now where there is n, I'll put a 4. Now it's 2. Our a, the first term, it's a 5, plus our n, 4 minus a 1. Then our d, you'll go on to use your formula: 5, 10, 15, 20, 25. This is our sequence. Then we have our T2. For us to find D, we'll use this T2 minus T1 is equal to a T3 minus T2. Our T2 is a 10 minus 5 is equals to T3, 15 minus 10. 10 minus 5, we get a 5 is equal to a 15 minus a 10, we still get a 5. Therefore, we conclude our D is actually a 5. Then we go back to our sum. On our formula, we have to substitute our D. We found our D to be a 5. Then our sum of the first 4 terms, we get, so you will have to punch these on your calculator as it is. Then you'll get that the sum of the first 4 terms on this sequence, you'll get a 50. For example 1, for our example 1, we will have, let's go for, you're given the sequence, you're given the sequence 2, 4, 8, 16, 32. The first question is find the sum of the first 4 terms. So, before we go on to answer the question, we must firstly go to the formulas under geometric sequence. So, our sum formula, A Rn minus 1 all over R minus 1. Our condition is R being greater than 1. Another formula is sum formula 1 minus Rn all over 1 minus R. Our condition when R is less than 1. So, on our sum, we are seeing that we have the sequence 2, 4, 8, 16, 32. Then, firstly, we will have to find our R. which is on this formula, our A is still our first term. Our R, it's our common ratio. It's common ratio. Our N is still the number of years, number of terms. Our N is still the number of terms. Then condition R is supposed to be greater than a 1. So our ratio for us to use this formula must be greater than a 1. In this instance, we are still having what? The same naming. A is the first term, R is the common ratio, N is the number of terms. But now what changes is the condition. For you to start with a 1, subtract R to the N, it's when your R is less than a 1. So let's go to our example. Given the sequence 2, 4, 8, 16, 32, find the sum of the first 4 terms. So Roman figure 1, I will go on to find R, our common ratio, using the formula T2 divided by T1 is equals to a T3 divided by a T2. Our T2 is a 4, our T1 is a 2, our T3 is a 8, our T2 is a 4. 4 divided by a 2, we get a 2. 8 divided by a 4, we get a 2. Therefore, our ratio for this sum in particular, our ratio is 2. So now, Roman figure 2, we now answer the question. Find the sum of the first 4 terms. The sum formula, you look into our R. Our R, this R is greater than a 1. So we'll go for the first formula, which is sum of n terms is equals to an A R n minus 1 all over R minus 1. So the question is, find the sum of the first 4 terms. So we take our n to be 4. So it's a sum of 4 terms. A is our first term. Our first term is a 2. Our R is a 2. Our n is a 4 minus a 1. Our R is a 2, subtracting a 1. So the sum of the 4 terms, you will go on to punch this exact thing on your calculator. Then you will find that the sum of the first 4 terms, it's a 30. Example 2. So for example 2, we are given a geometric sequence. 3, 6, 12, 24. Then let's just leave these as they are. Then we go on to have our first question, which will say write down the next two terms. Our second question is find the sum of the first 5 terms. Find the solutions for our question. First question, since we're given a 3, 6, 12, 24, which is, we can just bring it down to a 3, 6, 12, a 24. Then we have these, and our first question was to write down the next two terms. So for you to find the next two terms, you are firstly required to find our common ratio using the formula T2 over T1 is equal to a T3 all over a T2. Our T2 is a 6 divided by 3. Our T3 is a 12 divided by a 6. A 6 divided by a 3, you get a 2. A 12 divided by a 6, you get a 2. So now that we have our ratio, we conclude that our R is a 2, which is our common ratio. But A, so this will be like our Roman figure 1 in answering A, where we are required to write down the next two terms. So our common ratio is a 2, meaning that now moving from the first term to the next term, the second term, we used our ratio as 2. So it was a 3 times a 2, it's a 6, as much as a 6 times a 2, we got a 12. Also, our 12 times a 2, we got a 24. So we'll use the same procedure as to say 24 times a 2, we get our 48. 48 times a 2, we will then get our 96. Then the next two terms is 48 and 96. We've answered our A, we then go on to find B, but you can just conclude down here. Say this is T1, T3, 4, T5 and T6. T5 is a 48 and T6 is a 96. Then we are done with A. We can go on now to find our solution for B. Find the sum of the first 5 terms. So we need a sum formula. Our sum formula Sn is A. It's A Rn minus 1 R minus a 1 on our condition that our R is greater than 1. Our first term for this sequence is a 3. Our R, for our R we got a 2. Going back to the question, find the sum of the first 5 terms, making our n to be a 5. So here we are finding the sum of 5 terms. So where there is n, I place the 5. Same goes, here's my n. I'll place a 5 minus a 1. Then my R is a 2, subtracting a 1. Then my sum of the first 5 terms, you'll then punch this on your calculator. You'll get that the sum of the first 5 terms is a 93. Given a geometric sequence (40 x 10 5. Our first question is to determine the value of x. Our B is find the sum of the first 3 terms. So going for our solutions, our A, they want us to determine the value of x. We are given a geometric sequence, 40, T2 is x, T3 is 10, T4 is 5. So Roman figure 1, we are given 40, x, 10, 5. Then to find my R, I forever go for the formula T2 over T1 equals to a T3 all over T2. My T2 for this geometric sequence is the one that is our unknown, which is our x all over T1, which is 40. Our T3 is a 10 all over x, which is our T2. Then from here, we go on to cross multiply, where we say x times x, we get x times x being equals to a 10 times 40, or 40 times a 10. Then x times x, we got an x squared equals to 40 times 10, we get a 400. So we can either remove the squared by putting a root, then plus or minus a root of 400. The root will cancel the square. We remain with x plus or minus 20. So, since our geometric sequence 40x, 10 and 5 will then conclude that therefore our x is our positive 20. Therefore, we have our sequence is 40, 20, 10, and 5. We have our sequence is 40. We found the value of x, we got a 20, then it's 10 and 5. So for B, they said find the sum of the first 3 terms. So we firstly have to find our R using the T2 all over T1 formula, B equals to a T3 all over a T2. Our T2 is a 20 all over 40. It's a 10. T3 is 10. T2 all over 20. It's a 1. How many 20s are in 40? We have a 2. 1. How many 10s are in a 20? That's a 2. Therefore, our R is a 1 over 2. So, for Roman figure 2, they said find the sum of the first 3 terms. This is our n. So, we go to our sum formula. Sn, it's a 1 minus r to the n all over 1 minus r. Then sum of the first 3 terms, my n is a 3, my a is a 40. Let's use our square bracket. 1 minus my r, it's a 1 over 2 to the 3, close the bracket. 1 minus a 1 over 2. You will then punch this on your calculator as it is. Then you'll find that your sum of the first 3 terms is 70.